utan jag tänkte låta Kieran komma här. Och han kan Dante, han är från Audionate, han är utmärkt på de bitarna. Är det någonting som ni behöver veta om Dante så fråga Kieran, för han kan.
Thanks. I was using your VGA actually. Yeah, the scaling works. Analog. There you go. Oh, excellent. That's nice. If we could stick it in over there, we're probably good. So I've been slightly defeated this morning, which may be a relief to everybody. I've been trying to download my PowerPoint presentation from a web server in Australia, and it's taking a bit too long. So I work for a company called Audionate. We are an Australian-founded company. Audionate was founded in 2003 and was essentially caused by Motorola Advanced Networking closing their R&D lab in Sydney, Australia, which left our founders looking for a job. So, like all good things, they went and found some funding for a government-sponsored institution, which is called the National ICT of Australia. It's a bit like the Australian version of something like the Fraunhofer Institute. And they spent 3 years developing Dante, which is a method of transporting highly synchronous, low-latency media over standard IP networks. In 2006, NICTA decided to spin Audionate out as a company, and since then we have grown to having initially a corporate office in the United States, and then in 2010 I set up the Audionate presence in Europe, in the UK. When I joined the company in 2010, there were 18 of us. We're now 44 as of the end of this week, and we're increasing our presence in Europe. We've doubled the size of the company in the last 3 months here. So has anybody used Dante? Oh, great, that's good. Okay, so when I came over to the Rikstheater in it would have been 2010, I think, we had probably 5 manufacturer licensees, and today it's closer to 220. So it's grown quite large. Initially, we started in live sound. Our first product was was Dante inside the Dolby Lake processor, which was very cool. And now, as of last week at Pro Light and Sound, I think every live sound console manufacturer has a Dante solution. So there are 2 ways of doing audio transfer in live sound now. It's analog or Dante. That was because of the announcement of Avid. They now have a Dante card in their live consoles. SSL now have a card inside the new SSL live console, which is an interesting tale. And then Roland have one. Yamaha obviously have lots of Dante. Digico have just released a high-density 64-channel card, which goes in all of their new S21 range and the stage boxes. Yeah, they're... Sorry? Yeah, DN9650, it's been around for years. Yeah, absolutely. And there's cards, the M32, a 64-channel card, and obviously the X32 from Behringer has the same card. Obviously, different card, sorry. Yeah. Whoops. So, who else does live sound? Yeah. So, and Kadak have Dante solutions for for their traditional theatre market. Stage Tech also do. So yeah, that's a nice, happy community. We're also doing a lot in broadcast. So yeah, obviously Soundcraft and Studer have those. DHD have been showing stuff. AEQ from Spain. Yeah, huge number of broadcast products. We did a specialist broadcast show in March in London, and we had 25 broadcast manufacturers all show up. We had something like 70 products plugged into each other, and it was it was a stressful venue. We loaded in at 8 o'clock in the morning, and we had audio flowing by 9, including setting up the tables, getting everything up the lift, and yeah, it was a fun load-in. In fact, the nice thing with that was that we had a really good audience. They showed up at 10, but the really nice thing was with the manufacturers' representatives, they just couldn't believe how easy it was. Yeah, just plug it in. Well, here's Cat 5. Go on with it. And yeah, it all came up. So we've been looking at trying to get the whole signal flow. Consoles are obviously an important place, so the console manufacturers are great. But an audio system is fairly useless without microphones. So in terms of microphone manufacturers who are shipping products today, there is AKG. Recently, they just released a 2-channel in the, I think it's the DMS 8000 is the new microphone they made, the new radio mic receiver. Sennheiser have it in the Digital 9000 system. I had one in my office the other day. It was great. I could have... Yeah, pretty toy. Shure have it in the ULXD systems and their Microflex for corporate. And Audio-Technica have a range of power over Ethernet endpoint microphones, which are also very cool. So Shure, Sennheiser, Audio-Technica, AKG. And there are some other microphone manufacturers that we're working with at the moment as well. But they're the principal major microphone manufacturers that you see every day. So microphones is a good story. In terms of loudspeakers, we're more and more doing direct integration into loudspeakers. Started smaller. So PreSonus have a kind of small active box that has a Dante socket on the back of it, which makes life very easy to do. Nexo have various solutions in the amplifiers at the moment, and I imagine that may expand. There are some other speaker manufacturers in the kind of larger touring side of things who may have or may not have products, which people may or may not know about, but I couldn't comment. There are other amplifier solutions, so Labgruppen have a long time had a Dante integration since their acquisition of Lake from Dolby. And that's in the PLMs and in a large variety of amplifiers. So we do have a complete signal path. There's something like 475 products available today that you can just buy, which is nice. And I think we're working on an equal amount at the moment in development. So my time has been largely over the last 4 years dealing with product integration. So I've been doing the electronic and software design with our partners to get Dante into products. I've done about 220 different products. It's quite a frightening amount of work. And I'm expanding the engineering effort in Europe to cover the demand for that at the moment, because there's a lot on, and I'm doing more of the stuff I enjoy now, which is coming and speaking at events like this and showing off this technology. So the main motivations of what we do. The first thing we found is you have to take the world as you find it. So in 2003, the major breakthrough in networking technology was that gigabit Ethernet was actually becoming very affordable. To the extent that now in 2015, you wouldn't consider buying 100 megabit Ethernet for a new installation. The cost is the same as gigabit to all intents and purposes. Gigabit's so cheap, and that's really what facilitates doing this low latency, high channel count audio in a local area network. And that just makes it a no-brainer. So that it can be done on standard gigabit Ethernet switches is great, because you can walk into a supermarket even and buy a switch that will probably do several hundred channels of Dante. We have an internal competition in the company who can buy the cheapest switch, which is a bit unfair because we have some guys who work in Hong Kong and they always win that one. They just go down the local shop. I bought this terrible little switch from Amazon for €20. And that's fine. I've tested that with over 700 channels, little 5-port switch, no problem. I probably wouldn't use it on a gig because it's got one of those nasty wall-wart power supplies and someone's going to trip over and pull it out. But just for intellectual fun, I did pick up a switch in Hong Kong for €5, and that actually works okay as well. And it's great. It's pocket-sized. I can carry that around. Again, maybe if you're doing a production, you might want to spend a little bit more money. And the really, really key thing with that is that in enterprise, where there are existing networks, you can just plug into a network, and certainly with enterprise switches, you can function them so that they work just fine along with all the other traffic. So the major market holder in that is obviously Cisco. They have somewhere between 70 and 74% market share. And then the next nearest rival is probably Hewlett-Packard. And there are just hundreds of installations where we've just sitting on a common infrastructure with the corporate IT. The interesting thing we're doing at the moment is education for people who work in that converged enterprise space. So when you look at doing a building installation, 40% of the cost of putting the audio and video systems in is probably cabling and labour to do the cabling. If you can use the existing IP infrastructure, you can save a huge amount of money and time and get a lot of flexibility. So what we're finding now is the major education side of things is educating AV integrators on how to talk to IT managers. Because both disciplines have their own specific sets of jargon, and they're quite protective of it. Certainly audio people are incredibly protective of it, and IT people are just the same. What tends to happen actually is that I tend to find with AV guys, they know quite a lot about IT. Actually, they have a very, very firm understanding of their craft and a surprising amount about IT networks. Some of the terminology isn't so precise, which is what upsets the IT guys. Having a foot in both worlds is quite funny. I was at a major fund manager in the City of London the other day. Strangely enough, they have some security concerns. You know, they've got a couple of $100 billion in management, and they're a bit worried about someone coming in and taking off them. I can understand. But the conversation with their IT director took 6 minutes. I sat down and said, look, it works like this, it does this, it does this. Well, what if I want to do this? Well, why would you want to do that? I don't, so don't. Okay. Oh, this is easy. So, yeah, I could describe to you how I would do a penetration attack on your network using stuff, sure. But there's the one key thing we've just discussed. You're not going to let me deep enough into the network from the outside for me to be able to execute on that. Well, yeah, damn right. I wouldn't. Yeah, and if I could get that deep into your network, I certainly wouldn't be looking at your audio system then. Be heading for the cash. So, yeah, it's a case of having that conversation. Obviously, if you can get into the communications closet with a serial cable, you can do anything you like with any IT network. And that's the main thing to bear in mind with those kind of things. Those guys like locked doors, they like security guards, they understand that stuff. So a lot of what we find are people talking about IP addresses. This is because a lot of the equipment that people have used with audio systems so far for configuration has relied solidly upon people typing in manual IP addresses, whereas the world of computing has been kind of over that concept since about 1994, really. Even infrastructure switches now use hostname-based discovery. You know, if you go and administer a Cisco network for enterprise, everything's got a host name. They don't care about what the IP address is of the microcontroller inside the switch anymore so much. You can still do it, of course, if you want, but it's more efficient to ask for a host name. And that's how Dante works. You can, of course, have static IP configuration, but one of the things that we found was automatic configuration is what everybody expects. They just want to plug something in and get on with their job. Which leads me to the whole point about why bother doing media over IP. Okay, so I'm sure, how many people have used MADI here? Yeah, okay, so this parallels what happened in telecommunications. Telecommunication circuits were all TDM based. TDM is a great way of, putting information into a time slot, pulling out the other end. If you're using close to the maximum bandwidth between 2 points, TDM is incredibly efficient. If you're using granular point to multi-point systems, IP has some compelling arguments for it, but at the cost of having a higher overhead. So without a doubt, IP-style networking, in terms of actual media to size of packet, is less efficient. It's just a given. But we live in a bandwidth-rich world now. That's why I was saying gigabit really, really changed the game for us here. So bandwidth has become cheaper, and so we've got IP. Now, the other thing is you're going to get a slightly higher latency in order to packetize IP audio certainly effectively. If you think of a normal audio sample, yeah? If you're using a 32-bit audio sample, yeah? It's tiny, it's 4 bytes. You can cram 1,500 bytes into an Ethernet frame. So it makes sense that when you write the source address, the destination IP address, the IP header, all of which are quite big, if you're going to use a 32-bit source IP address, that's already the same size as your audio data of one sample. So the trick is you have to wait around for a few samples to show up to put them together, otherwise you end up with this grossly inefficient way of moving stuff around. Now, unfortunately, we have to wait about 20 microseconds per sample for them to show up at 48K. So we might wait around 4 samples to show up. And if there's some more channels going that way, we'll cram the channels into the same packet to move it. So it's not as low latency as a TDM-based system, but it has the flexibility of being able to do very, very granular, very rapid routing. So there's a trade-off. From a technologist perspective, and that's where I live, if there was one technological answer to everything, 80% of the industry would be out of a job. Thankfully, human beings are great, so there are many, many different ways of solving the problem, and I would encourage people to have an informed debate about what is it they actually want. So, okay, cool.
What that is good for and how
Yeah, sure.
it works. So we're
Okay.
down to the future. This is a really high technology.
That's perfect.
What we think that PowerPoint?
So, the really compelling thing with any kind of media is that it's nice to move, say, audio or video around, but it's even nicer to know what it is. So, there's always been the concept of metadata, certainly in broadcast. And in a unidirectional system, with using AES3 or MADI, you would use the user bits to signal some very, very, very sparse information about what the media payload was. And you'd have no idea whether it got to the other end. So you just have to keep sending it. With an IP system, because you can send as many different kinds of protocol, and sometimes you want to know whether it got to the other end, sometimes you don't care. Sometimes it's a bad thing to know. So we'll talk about different transport mechanisms, but the fundamental concept is, we've experienced this for years on the consumer end. I'm sure everybody uses radio stations streaming on the computer. And it will show you the band, it might show you a link to their website, it might show you their album cover. And that's because the internet browser you're looking at knows what the content is. And this just isn't done in a broadcast environment very much. I don't see why not. Using an IP system, we can know what channel someone's subscribed to. Dante will tell you that. If you bother to update your playout machine with what the content is on that particular channel, you can push all kinds of rich metadata. And it's a conversation I'm beginning to have with broadcasters. We don't provide a system for giving metadata. We provide a system for knowing what's going on with media. But we also provide an API. So there's a whole bunch of broadcasters now going, hang on a minute, so if I take my laptop and I click on this source, your system knows who's listening and when they started listening, when they stopped listening. Yeah, and you can just pull that as a linked list using the API, and you can do with that what you like. It's not a problem. So yeah, you could push information to people, and also in terms of content security, which everybody is paranoid about with networked audio systems, the most important thing you can know is who got it. And you know that. So if you look at Dante Controller, that nice green tick that comes up is a very, very, very basic graphical representation of we know who's got that and exactly when it started. It all gets spat out underneath as text, and you can go and interrogate that using the API, and you could save that in a database. You can do it's just data. So there's a load of powerful applications, and we just expose all that. There's huge amounts of information that we don't bother displaying in the controller because for its purpose of a simple router for getting a show up, it does what it's supposed to. But there's a whole layer of information underneath that is accessible, and that's the really useful thing with any IP transport. So I discussed that it's not the most efficient point-to-point system. It's incredibly powerful for point-to-multipoint or complex infrastructures with many different points. It's also really great at providing information for analysis, and because it's essentially a system that allows you to sit next to any other kinds of traffic, you can send any information next to it that you like based upon standard big data analysis. And I hate to use that buzzword, but everybody loves big data, of course, I'm told. So our current offerings, these 220 manufacturers, we're essentially a software company that makes some hardware platforms to make sure that everything interoperates. Because it's nice to have the concept of moving audio between points, of course. But we use standard methods for doing that. We use UDP/IP at the transport layer currently, and this is part of the overhead discussion. So, is everybody aware about UDP/IP and TCP/IP, which are the two main layer 4 transport protocols that you see every day? Okay, so what we do, because we're dealing with low latency, is we use this system called UDP, which is above. The UDP sits on top of the IP layer. So there's something called the OSI model. So down at layer 1, we have the physical layer. That's your wire or your fiber. Okay. Okay. So physical layer is your wire or your fiber or your radio waves even. We're not so good on radio waves, but that's the physical medium. And down there, this basically describes how bits get stuck onto that medium. So just how the pulses get conveyed. And that's fascinating in itself. How do you get a reliable pulse down a piece of fiber that's 20,000 kilometers long? That's a whole fascinating world of science there. It's cool. We have very little to do with it as a company. We let people who know about that do it. Switch vendors are really good at that, so they do that bit for us. And then layer 2 is is what they call the network layer, confusingly. And that's where you've got MAC addresses, yeah. So you can send. This is where this defines every single entity has a universally unique identifier, which is great. But it means that any device with a MAC address can shout at all of the other devices. It's not so bad in a small network. The way I tend to describe this is if we're all in a room like we are today, anybody here can speak and everybody else can hear. That may be good and that may be bad. But at a certain point, if everybody starts chattering, it's going to get very, very noisy. And it becomes really, really, really difficult to communicate. So then above that we have layer 3. Sorry, this is the data link layer. Sorry. Feel free to shout out. I'm 2 time zones wrong, so it's very early in the morning for me. Layer 3 is a network layer, of course. And that's where we have IP addresses. Okay. So we have a concept of, in terms of physically, we have on layer 1, on your wire, we call that collision domain. So that's where 2 bits can crash into each other if they're sent by 2 different things. If you remember back in the old days when we were using BNC cables between computers to play network computer games, there's a whole lot of work done down there to make sure that you could actually reliably shoot somebody and That's what I used to use it for. It's great. That's when I was about 16. I was really interested in moving audio over networks, and it was not understanding what collision domains were that is why I couldn't understand why it could not be done. Because we're talking about reliable timing. If I have a bunch of things sitting on the same collision domain and they all fire off at the same time, you just get nonsense out. So it's very, very difficult to reliably time multiple points on the same collision domain. So the collision domain is segmented at this layer. That allows you to start the concept of he's talking to him, he's talking to her, she's talking to her over there. So you have point-to-point communications. But you're still in one room in this case. This is what switch does at layer 2. Layer 3 breaks up what we call the broadcast domain. So layer 3 is really IP addresses of what routers do. I'm sorry to use the American pronunciation, but I do have a reason I use Linux as well. And it gets very, very confusing. If you talk about routes, are we talking about the root login? Or, yeah. So we use router because it's just the wrong way to pronounce it, but it differentiates nicely. What that does, that's like having a telephone in the corner and talking to another room. This means that if people are shouting, you can still be heard with a specific connection to a remote site. Okay, so this allows you to scale up to a global scale. This is okay. So chatting about this is an IPv4 paradigm of expressing a IP address, and I'm sure people are aware that IPv4 has technically run out of addresses, and there are some beautiful, elegant cheats to get around that, which is why the internet hasn't broken yet. IPv6 encapsulation and all those kinds of things that telcos do, but IPv4 is nice because it's human readable. And you could nearly memorize it. I can't do IPv6 in my head, it's just massive. And has some different concepts. And then above this we have what we call the transport layer. And this is becoming more and more in the realms of software. This is where things get more conceptual. So the two main transport layer protocols that we use are called UDP/IP and TCP/IP. And they're called that because they sit on the IP layer. So the main difference between these guys is UDP is what we call an unreliable transport protocol. It fires and forgets. So if I send a UDP message to a remote device, I don't care whether it got there or not. That you would have to build something into what you sent to make sure that the other end understood that they were getting things in order. But what it does mean is that I can fire a lot of stuff off, and for real-time communications, it's the best way of doing stuff. Because if I have to go back and get an audio sample, it's going to probably arrive too late. And that transaction will get in the way of the stuff that may be on time. So it's that's why we use this. It's better just to drop it and carry on. Many people are musicians. Yeah? So what do you do if you're on the stage, yeah? You make a bum note. You don't go back and try and play it again, do you? That's the art of being a musician. You just carry on. Yeah? It's like, otherwise you can go and cry in the corner and never succeed. That's what UDP/IP does. TCP/IP is like those. I've seen it occasionally. Someone screws up right at the beginning of a gig and they go, oh, let's do it again. There are limited circumstances where you can carry it off, and it requires a lot of confidence. Computers aren't emotional, unfortunately. Although they cause emotions, don't they? TCP/IP uses a three-way handshake mechanism. So what it does is it sends this guy. He sends something back. So he goes, here's a packet number 1. He goes, send me 2. He sends 2. And he send 3. Yeah? That's great. And if one gets missed, it says resend. But that has a huge overhead because effectively it's handshaking all the time. I'd quite like my salary to get paid into my bank account using this method, all right? I don't trust them. If they put some extra noughts on using UDP, that would be great, but that's just not going to happen. It's just going to come out as naught, isn't it? So that's good for transactions like that. Web pages are done like this because the public internet is notoriously unreliable at actually delivering packets in order, and sometimes they get lost. And this is the major concern. Everybody has experience of using Wi-Fi, using the public internet. So the question that comes up a lot is, what about drop packets? Well, in a wired network that's well engineered, that hasn't got the rest of the universe plugged into it, drop packets are incredibly rare. I wanted to prove this to myself. So I plugged in a bunch of gear. I had 128 channels moving around a network, and I just put it in the corner and left it. We have a mechanism for finding lost packets, well, knowing that they were lost. 9 months later, it hadn't dropped a single packet, and I had to conclude the experiment. I had to use the equivalent of something else. So if you're thinking 48 kilohertz, 128 channels, 24 hours a day for 9 months, and it hasn't lost a single packet, it's quite good. If I tried to put that over Wi-Fi, I would have thousands of lost packets in a day, because Wi-Fi is a single collision domain. It has to do all kinds of stuff to prevent collisions, to work out what really went where, because you've got this single physical medium that's the air. It's a bit smarter than that. There's a lot of smart stuff gone into it, but yeah, ultimately it's very, very difficult to time reliably over 802.11 Wi-Fi, which is why we don't try and do real-time audio on that. There's of course nothing to stop you using compressed forward error correction codec, which are effective, but you're going to have a latency of several hundred milliseconds to do that, which for some applications is totally suitable. So this is all stuff that you can read about from the IETF, from the well, IETF is the whole stack. There's a few layers on top of this which deal with how to break down large files and how to deal with security and how to present it to an operating system. But so IEEE deal with this stuff. IETF tend to be the software hippies that talk about esoteric, interesting ways of moving networking stuff around. But they're two really, really great large standards organisations that discuss stuff daily. That stuff's very cool. So Dante sits on top of all of this standard method. We use the general IP stack of Windows and Mac OS to move stuff through. It allows us to have web pages alongside it, to have voice over IP running alongside it. It really, really helps, make a single cable solution for data communications. So there are some other standards that have come out, and those are good things. So we'll refer to it briefly because this is something that often gets terribly confused. Journalists love using different words for the same thing. Because if I read frame, packet, it gets really, really, really boring really quickly, doesn't it? So people like to use different terms because it makes nicer literary reading. Unfortunately, it makes appalling technical reading. It causes all kinds of confusion. So above the transport layer, and I promise this is the last layer we're going to bother with, layer 5 deals with segmentation. We're not so concerned about that with audio because audio is tiny. But if I want to download via FTP an album, refer back to this layer. I said that on Ethernet, which is layer 2, the maximum transmission unit of an Ethernet frame, which is the correct word, is 1500 bytes, 1508 or something close to that. An entire track as a file is much bigger than that. So if I send a request going, give me this track, the server's going to go, no, the server is not going to turn around and say it's more than 1500 bytes. No, it's going to go, yeah, okay. So there's a segmentation layer which chops it up into understandable parts, passes it to the transport layer, which moves it across the network. So that's, in terms of an audio stream, we never get above 1500 bytes, so the segmentation section is academic. It is there, but we don't really have to use it. For video, for frames of video, it becomes very significant indeed. And for segmenting for segmenting data in order so it's understandable by these layers is really important for IP video, certainly. But that's where RTP sits. People heard of RTP? Okay, so RTP is a mechanism that's used in many, many ways of moving media around, real-time protocol. And that deals with, it's useful for dealing with descriptions of media, it's useful for dealing with larger bits of media. RTP is used, they call it a transport, it's not, because it actually sits on top of a combination of UDP and TCP/IP, it's actually layer 5. The reason why I mention it is because AES67 has a profile of RTP for real-time low-latency audio. Well, that just broke the world. So the main reason why we haven't used RTP in Dante to this point is because if a single vendor tries to define an open standard, everybody else is going to turn around and try and do it a slightly different way. AES67's finally put in a serious piece of that jigsaw by defining RTP, and everybody's agreed to it. If the profile of RTP that we require for real-time audio had existed back in 2003, chances are we would have used it. It existed in 2014. And so we're including support for AES67 in Dante to our manufacturing partners as of the end of this month. So what does that mean? Wow, that means we have to change all of this stuff. No, of course we don't. We stick 12 bytes on the front of the packet and off we go, because it's just a description. In fact, what we're doing is we're basically taking a description we already had, duplicating it and shifting it slightly further forwards. It just goes in a different slot in the overall architecture of the packet. It's very, very insignificant. Because we had to have something that does the same function anyway, otherwise it just wouldn't have worked. So the other things that are important is AES67 defines timing. Strangely enough, it's defined a good way of doing timing as IEEE 1588, which has existed for a long time. Well, it's first got ratified in 2002. We've been using it since the beginning as our timing method. It was originally developed for synchronizing robots in car factories. I think Toyota were one of the main contributors to it. It's very, very cool. It's very, very simple. It's an isochronous clocking system. What that means is that you have the concept of master clock, just like you would in any other digital system, and you have slave clocks. But unlike a synchronous serial system like MADI or AES3, where you have to send every single word clock cycle down a physical cable, you have the concept of an isochronous clocking system. So the master clock sends out information about time. So it's not clock, it's time. So it's like having two high-quality watches or two low-quality watches. You say it's 8 o'clock now, and the clocks carry on, and they're inevitably going to drift apart a certain amount. 1588 sends that synchronization signal a number of times a second. That's left undefined. We use a certain rate. Other people use much higher rates. AVB, for example, uses a profile of 1588, but a very, very high density clock rate. There are some reasons for doing that. The main reason for sending at a higher density is it allows people to use different clocks. So if I had a really high quality Rolex watch and I got some kind of knockoff in a market, to keep those two clocks together I would have to synchronize them more often because the drift between them is going to be greater. One of the things we found with our offering was that if we strictly defined the crystal that people use and the clock synthesizer chip and somewhat uncompromising about any alterations to that, we can precisely know what the offset between those clocks is going to be over time. It's the kind of thing, when you buy a high-quality watch, it says this watch is going to lose 1 second in 1,000 years or something, if you want some really, really expensive clock or something, yeah? That's the thing. So if we know what the hardware performance is, we can profile what we're doing with the network to do that. And so we can guarantee very, very tight clock synchronization rather than having a concept of, it might be a bit like this, but it depends on what you do. So that's the nice thing of open standards. Dante isn't a standard, it's an implementation of a whole bunch of standards. So, yeah. Sorry,
Time is running.
oh, okay.
So we could just direct you in to show us the Dante controller.
Sure, okay.
Because there will be a Dante controller on each
Mhm.
station.
Okay,
Please do run through on that.
all right,
And then we can start connecting and setting fire stuff.
fine. No, that's all right. So, just in conclusion, understanding the difference between a standard and implementation is important. Being open is also important. It's what people want. Do you want some open software where you end up having to write your own stuff, or this is the exciting new development that we've come up with. So, instead of just using hardware now, we have a new product called Dante Veer, which is a software solution that opens up hardware. So this is somewhat confusing. This is a normal USB audio interface from our friends at Focusrite. It's Focusrite Scarlett. I plug it into the Mac. The Mac is going to discover it because it's a USB device. I had my Bluetooth headset plugged into this the other day, and Dante Veer discovers any audio source in the computer. I can say, publish that to the Dante network. Then, using the Dante controller, which implements a bunch of software to discover devices, I can send this to... So the Scarlett comes up nicely here from my computer, and I can send this nicely straight to the Yamaha desk, which I did earlier, and I can use this if the desk's turned up. That will feed back. Right, and I can just use this as a preamp, and this is going through the USB, through the network stack, across to there. Now, I'm sure you can hear a slight latency on it. It must be about 25 milliseconds or somewhere around that. But in terms of just walking up with the equipment that you've already got, I could probably play drums to this, I think. But yeah, that's it. Essentially, Dante Veer exposes everything that your computer has in terms of an audio source and throws it onto the network. Because modern computers have got so powerful now, we don't even need a hardware master clock for this. So you could build a networked audio session between two computers without having any dedicated Dante hardware. We're about to go into the beta stage with this piece of software in the next few weeks, and we anticipate launching it in June, July. But yeah, it's like I said, with the switches, you want to use what's already there. Now we've got a solution where you can use the hardware you already own with the software interface. So you can have networked audio just by a low-cost piece of software to bridge everything together. We don't think it's going to harm hardware. What you're going to hear latencies like that. They're going to be unsuitable in certain environments, and a piece of dedicated hardware is always going to be superior. That's a given. But it allows people who are using this equipment to make purchasing choices based upon need rather than a requirement of someone to sell some new silicon. And we hope you buy our software. Dante controller is quite cool. So if I just unplug the network at the moment, everything's going to disappear, the world's going to end. Dante controller really does just, when you plug it in, does just discover any devices in the network. Probably after a brief pause and a restart. Come on. Software, eh? I love doing demos like this. It's just so great, isn't it? Come on. Yeah, it's thinking about IP addresses at the moment. Oh, did I just press that? Oh dear. Yeah, there we go. So it discovers all the devices. And we'll automatically make sure that the routes come back up again where they were last. Because the last thing you want is a power outage and having to frantically click through a few thousand endpoints. So every device remembers what it was receiving from. So if it loses power, it comes back up, it resubscribes. It's got some diagnostic information. So you can define who your preferred master clock device is. I'm not going to touch it, don't worry. You can synchronize to an external word clock source. So if you had a generator or a house clock in a theatre, that's easy. You just say, this is the point that's connected to the house system. Tells you some information about the network. It can also tell you about any errors that may have come up. So we've got someone's talking in Lilyhammer. Yeah, there you go. So we've got little signal presence meters. There's this screen is very useful. If you're dealing with a larger network, this tells you when the packets are actually arriving against your maximum latency. So anything to the left of this line is good. Anything to the right of it means that you've got stuff in the network being delayed, and it's probably a good idea to have a look at it. I would imagine those packets there are just when I took the cable out and it had to have a think about everything and resync itself. It's, as you can see, this line at 5 milliseconds is growing quite nicely now, so it seems to have got happy and settled down. But this is a really nice, quick tool for going through and seeing if your network's healthy. Okay, sorry, I really have overrun time badly, so if there are any questions, yeah. That's a great question. Actually, I'm going to show you something really quickly. This is something we've been discussing and debating hotly for a long time about how to do it right so it works for everybody. It's a complex question. The easy answer was that, hopefully, let me just kill this completely. There we go. That's right. Dante Via, as a new product, has taken quite a lot of this into consideration, especially as it's a massive security risk that you could listen to someone's built-in microphone on their laptop, which wouldn't be good if the boss was having one of those conversations in private and everybody else wanted to have a listen. So I have to actively turn Dante on for the device in the Dante Via control panel. And then, if I decide to take these channels and send them to the Yamaha desk, hopefully it won't remember the status. So I do that, it's saying, okay, go back to Dante Via, and in a moment it's going to say, oh, okay, what it should say, and because we've done this several times, first time you do it, it throws a splash screen saying, this guy wants to listen to this channel, do you want to let him? It's not the perfect thing you're after for locked routes, but it's the first evolution of what we're going to get to in the next 18 months to 2 years, where we're going to have the possibility of having full username privileges. So, you know, a bit like an Active Directory system, you know, you're going to be able to define who sees what, who's allowed what, whether it's read and write, you know, all those kind of privileges. The complication was, in a live sound situation, you want to be able to swap something really quick, and maybe you don't have time to put those security access privileges in. That was the tricky thing to solve. We think we've got that worked out, but it's just a case of software now. Any other questions? Let's go. Oh, sure.
If I have a backup hardware
Mm-hmm.
on my shelf, the main thing was off and I went to plug in my backup.
Sure.
What's happening to routing?
If it's say a stage box and it's transmitting, the receivers know the name and the channel name. So if you call that backup piece of hardware the same name and throw it onto the network, everything that was subscribing to that thing with that name that's blown up will automatically resubscribe to it.
Device configuration has to be exactly the same.
Just call it the same name. So if it's Stagebox 1 and Stagebox 1 breaks, just call the new one Stagebox 1, plug it in, everything that was listening to Stagebox 1 will automatically go to that. If it's receiving, it's slightly more complicated. You have to go and make the routes. But in the preset section of Dante Controller, you can push those presets quite quickly. So you can copy receive presets from a device you've got saved and push them to a new device. That's how we expose it on Dante Controller. If people wanted to build their own software application to do that kind of management using the Dante API, it's quite possible. Those things become much more specific in terms of markets. Certainly the broadcasters are really interested in building their own specific software for doing that, and we're quite happy to have that discussion with people. Quite a lot of people say that the routing matrix is the wrong way around on Dante Controller as well. So we have had partners who've specifically gone in and turned it around. Right, anything else? I'm going to be around for the rest of the day, so if anyone wants to play with Veer or have a look at some other Dante devices, please feel free. Okay, cool. Thanks.
Thank you, Kieran.